All right, sixth graders, today we're talking about the relationship between fractions and percents. Because percents are basically fractions where the denominator is always 100. Percents are always 100. Percents only come in hundredths. So let's take a look. Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statements. So let's take a look. If we wanted to draw a tape diagram, we'll do it like this. So how many vehicles do we have total? How many objects here? We've got 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, and 5. Well, how many of these are cars? 1, 2, 3. We'll color that in. And then we have 2 trucks. Now, another way of writing 50%, because like I just said, percent is just a fraction where the denominator is always 100. So 50% is exactly the same as 50 hundredths. Well, what fraction of the cars here are green? I hope you said 3/5. Well, can we turn 3/5 into a percent? Can we turn it into hundredths? Sure. But what do we have to do to this 5 to make it into 100? Well, you have to multiply it by 20. You know you had to multiply it by something to make it bigger. And if you do it to the bottom, you gotta do it to the top! So we multiplied the bottom by 20. So we have to multiply the top by 20. So 3 times 20 is 60. So we have 60 100ths, or 60%. So is Sam right? Sam says 50% of the vehicles are cars. Nope, Sam is wrong. 60%. Sam is wrong. Bummer, Sam. So how is the fraction of cars related to the percent? Well, percent is a fraction, but the denominator is always 100. Percents are a little boring. You know, fractions come in all shapes and sizes, halves, thirds, fourths, 627ths. But percentages, that's a fraction that's only going to come in hundreds, only divided into hundredths. So let's draw a model that would prove that fraction and percent are equivalent. Well, let's see, I'm going to have a pie. And I'm going to divide it into tenths, because tenths is easy to translate. No, that's ugly. Tenths is easy to translate into hundreds, but I'm not going to draw 100 little tiny slices of pie. That would take forever. So we've got half a pie. All right, so I have a pie divided into tenths. So I know that 1/2 would be like that. So that's 1/2. But then 50%, well, 50% is the same as 50 hundredths, which I bet you can see is the same as 5/10. I just chop off a 0, 5/10. So then I have, let's see, 1, 2, 3, 4, 5. Hey, 5/10 is right there. Oh, so yeah, 1/2, 50%, the same. And that also makes sense because 50 is 1/2 of 100. So it makes sense that 50% would be the same as 1/2. So what other fractions or decimals can represent 60%? Well, we know the easy one. We know 60 over 100, or 6 over 10, or, because if you divide both of these guys by 2, then we would get 3 out of 5. Or, if we want to go fancy with decimals, we can do 60 hundredths, because percent after all is just hundredths. Or, because this 0 is pretty unnecessary, we could say 6/10. So what I want to point out, this and this are both read as 60/100ths. This and this we would both read as 6/10ths. Cool. A survey was taken that asked participants whether or not they were happy with their job. An overall score was given. 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part-to-whole fraction for comparing happy participants to the whole. Then write a part-to-whole fraction of the unhappy participants to the whole. What percent are happy? What percent are unhappy? All right, so if we're going to do a part-to-whole fraction, then we need to figure out what the whole is. So we know that the part is 300. And oops, ooh, bad job, Mrs. Vandenhoek. Happy is 700. Unhappy is 300. So there's the part for each of those, but what's the whole? So how many participants are there total? Well, 300 plus 700 equals 1,000. Okay, so 1,000. So there's our fraction, 300 out of 1,000, 700 out of 1,000. So then what's our percent? Well, we can't do percent out of 1,000. That doesn't work because percent is only out of 100. But it's pretty easy to turn both of these fractions into hundredths. So what do I need to do to turn this 1,000 into 100? Well, I need to chop off that 0. And to do that, I have to divide by 10. And if I did it to the bottom, I have to do it to the top. So if I chop off a 0, divide by 10, then I have 70 out of 100, which you know would be 70%. And we're going to do the exact same thing over here. I'm going to divide by 10, bottom and top, and then I have 30 out of 100, which is 30%. 30 per 100. All right, in your small groups, get started on exercise 1. Good luck.